Here are the video solutions for NCFE Level 2 Functional Skills Maths. This is section B, which is the calculator test, and this is from the sample paper. So let's take a look at the first question, which is question number 2. So it's all about writing a figure in words. Now we just need to remember that words like 1,000, million, billion, trillion, let's replace them with commas. So 1,000, that's going to be a comma. So can you write 970? Hopefully you can. So that's 970, comma. And now you just need to write the next bit, which is 215. And you are done. And if you want, you can now take the comma away if you don't like the commas, but that is how you'd write it in numbers. So the commas are really helpful. Remember that when you're going from right to left, group them in threes, and after every three, put in a comma. The first comma is 1,000, the next comma is million, the next one is billion, the one after that would be trillion. So for the next question, we just need to work out 84% of 970,215, and what we need to do is 0.84 times 970,215. 0.84, that is the percentage multiplier for 84%. It's the decimal equivalent of 84%. It is 84 divided by 100, if you're wondering where that came from. And 0.84 times 970,215 is 814,980.6. Now we want to round it to the nearest thousand. So we've got units, tens, hundreds, thousands. So if we're rounding to the nearest thousand, we're interested in the value in the hundreds column. Now the value in the hundreds column is a 9, which is greater than 5, so the column to the left will move up 1, so that 4 will become a 5, and everything after that will become a 0. So 815,000. If you want, you can chuck a comma in. So 815,000. Okay, so we know that 7 centimetres on the map represents 0.35 kilometres. So as a ratio, we can write it as 7 centimetres to, what was it, 0.35, wasn't it? 0.35 kilometres. Now, it's much more helpful if we can get this ratio in units that are the same. So first of all, you could either turn the centimetres into kilometres, but it's a lot easier turning the kilometres into centimetres. Now, first of all, let's turn the kilometres into metres. Now, to turn kilometres to metres, we are multiplying by 1,000 because there are 1,000 metres in a kilometre. 0.35 times by 1,000 is 350. So we've now got it centimetres to metres, so now we can go 7 centimetres to how many centimetres in a metre? 100. So multiply this by 100, 350,000. Okay, so the scale is 7 to 35,000, but we want the scale in the form of 1 to n, where n is a number. Now to go from 7 down to a 1, we're dividing by 7, so therefore for an equivalent ratio we need to divide the other number by 7 as well. 35 divided by 7 is 5, so that is 5,000. So the ratio is 1 to 5,000. Okay, part D. What fraction of students travel to college by car? Well, there are 36 that travel to college by car out of a total of 52 plus 36 plus 28 plus 4, which is 120. So it's 36 out of 120. Now, on your calculator, you could type in 36 over 120 as a fraction, or you could type in 36 divided by 120. Remember that the line of a fraction means divide, and it's possible your calculator might turn it straight into the fraction in its simplest form. If not, look at the fraction and think, okay, maybe you've spotted that both numbers can be divided by 12. 36 divided by 12 is 3. 120 divided by 12 is 10. So a fraction in its simplest form is 3/10. Okay, so for this question, this is quite a complicated question, lots of bits and pieces, but the first thing it's saying is to use the estimated mean distance. So this is what we need to use here. Now, unfortunately, they've really not given us much space here. We know that 13 students travel between 0 to 1 kilometre. Now, these 13 students might live 1 centimetre away from school, or they might all live 1 kilometre away. So what we're going to do is we are going to assume that they all live at the midpoint between 0 and 1, which is 0.5. 1.5, 2.5 and 3.5. So if 13 students live half a kilometre away, then those students have a combined distance of 13 times 0.5. Quite often this is labelled as your frequency column, and we need to do another column here which is frequency times the midpoint. Now 13 times by 0.5 is 6.5, 1.5 times 11 is 16.5, 7 times 2.5, so as you can see we're multiplying all of these. 17 times 2.5 is 17.5, and 5 times 3.5 is 17.5. Now the estimated mean distance is going to be the total mean distance, so it's going to be the sum of these four figures divided by the number of students. The total number of students adds up to 36, and the estimated total mean distance comes to 58. So the estimated mean distance is 58 divided by 36. So estimated mean distance is the estimated total, which is 58, divided by the number of students, which is 36, and that comes to 1.61 recurring. Okay, so that's their distance from college, but if someone's travelling to and from college, then, so that's kilometres, then this 1.61 is going to be done twice, and 164 days of a year. So if this number is sitting on your calculator, just double it and then multiply by 164, and that comes to 528.4 recurring kilometres. So this is what every student does per year. Okay, now what other information do we need to play around with? So it says here that we've got the average fuel consumption is 38 miles per gallon. So if I can go to 38 miles per gallon, which is this line just in front of the 40, that will tell me how many kilometres per litre. So if I go up here and take a reading across, for me that is kind of halfway between these two lines. Using a pencil and a ruler will mean you get this a bit more accurately. So for me that is 13.5. So 13.5 kilometres per litre. Okay, so what do we do with this information, I hear you ask? So let's just have a look around. So the only other thing we know is it's 2.44 grams per litre of petrol used. Okay, right, so we need to work out how many litres are used. So if it's 13.5 kilometres per litre, and a student does on average 528.4 recurring, well, how many litres is that? Well, that is going to be 528.4 recurring divided by 13.5, and that comes to 39.144-ish litres. And we've also been told that it's 2.44 grams of nitrogen dioxide per litre. So if this is the number of litres, we now need to multiply the 39.144 by the 2.44, and we get an approximate total of 95.511. Does it say how many decimal places or anything? No. So I'll just put 95.511. I've done a little bit of rounding there, and it's possible you might not get exactly the same answer, and the main reason why is you might have got a slightly different reading from the graph than I did, but as long as you've shown how to get it and your answer is within the acceptable range in the mark scheme, you'll be fine. So, you know, as long as it's fairly close to 95.5, then I'm sure it will all be fine. Okay, so on to part F. So for this question, first of all, let's have a quick read. So we are reducing from 55 to 35 micrograms of nitrogen dioxide. So we need to take readings of 55 and 35. Now, first of all, what we need to do is draw in a line of best fit. Now, the line of best fit normally cuts through the centre of the dots. This one, the dots are more or less in line, so we can more or less do a straight line. So I would say the line of best fit is going to look like that, more or less, give or take. Okay, so what do we do now? We go up at 55, so that's halfway between 50 and 60. So draw a vertical line using a pencil and a ruler, and we can see it hits the line at this point here. Now, ideally I'd have done that line a little bit thinner, but I can't on this this computer package. So as I go across, that is 1.31. So let's just make a note of that. So 55 gives me, I've already forgotten what I said, 1.31. And what about 35? So exactly the same thing. So here I'm going up at 35, halfway between 30 and 40, and for me it hits the line there, which is 1 less than 1.35. So I'm going to go for 1.34. You might slightly disagree there. Okay, so what is the difference? Well, 1.34 minus 1.31 is 0.03, and we need to give your answer as a fraction of a litre, or 0.03. If we've got 2 decimal places, we're talking in 100ths, so that is 3 100ths of a litre. So there we go. And I believe in the mark scheme there is a range of answers that are acceptable, again because reading the graph isn't that straightforward, and you might have drawn a slightly different line of best fit to what I've done. Okay, moving on to question number 3 now. So we need to do a 6x5 rectangle. So nice and easy. Let's just, I'm not going to go upwards because that would take me off the grid. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so what do we need to label? Do we need to label them B, C, D? No, we don't. We just need draw one possible position for the label on the grid. Okay, right. So again, using a ruler probably would have been better here. And write the coordinates of each corner. So this corner, remember we're going horizontally then vertically, so that is 4, 3. This is, scroll down a bit, this is 4, -2. And this is, if it was a straight line, -2, -2. So there we go. We've got all the corners. So how many do we need? Okay, we need all 3. Okay, perfect. So we want to calculate the volume of this box. It's a cylinder. Now the volume of a cylinder is the area of its face, which is a circle, times the height. Now the area of a circle is pi r squared times the height. So this is here is the formula for the volume of a cylinder. We've been told pi is 3.14, so it's 3.14 multiplied by, okay, now the diameter is 11, so therefore the radius is 11 divided by 2, which is 5.5, so 3.14 times 5.5 times 5.5 times a height of 22. And what does that come to? Let me just scroll down a little bit. That comes to 2089.67 cubic centimetres. There we go. Okay, so for this question we know that the target weight is 294 and it's rejected if it's less than 98% of this. So what is 98% of 294 grams? Well, the percentage multiplier for 98% is 0.98 times 294. This figure is the decimal equivalent of 98%. It's 98 divided by 100, and 0.98 times 294 is 288.12. So how many are less than 288.12? There's 1, there's 2, there's 3. So there is 3 out of 2, 4, 6, 8, 10. So the probability of it being rejected is 3/10. It says here, what's the probability that the next 2 will be rejected? Well, that's going to be 3/10 times by 3/10, and that is 9 100ths. And when you've got the fraction out of 100, you've got your percentage, so that is 9%. You might have written 3 out of 10 as 0.3. 0.3 times 0.3 is 0.09. Here you've got a decimal with 2 decimal places, so we're talking hundredths, so 9 over 100, so still 9%. So that is our answer. Okay, moving on to this one here, we are comparing this between, we're comparing these values to 294. So this is bigger than 294, so it would make sense, so it's going to be a plus. So what is 294.04 take away 294? The answer is 0.04, so this is plus 0.04. This is less than 294, so let's do 294 take away 293.71, so it's less than, and that is going to be 0.29. This is also less than 294, so we'll do a subtraction here, so 294 take away 292.59, and we get 1.41, and that's all we need to do for part D there. Okay, let's have a look at E. So we know the ratio mint to caramel to fudge to toffee is 2 to 3 to 3 to 1. So what we can do with this ratio is turn them into fractions. We've got 2/9 of mint, 3/9 caramel, 3/9 fudge, and 1/9 toffee. And we're dealing with ninths because 2 plus 3 plus 3 plus 1 is 9. So if 3/9, we're interested in the fudge. So fudge should be 3/9. Now this fraction, if you want, you can simplify it, is 1/3. So a third is supposed to be fudge. So if there's 27, what is 1/3 of 27? Well, that is 27 divided by 3, which is 9. So per pack there should be 9. We've been told that there are 8. So it does not contain the correct number of fudge chocolates. So is she right? Case is wrong. You could just add in there should be 9, not 8. Just to be on the safe side. Okay, so what is the mode? So the mode is the value that is the most common or the most frequently occurring. So let's go through them one at a time. So 194, 2, 3, 4, 5, 6. So 1494 is times 6. So let's just get rid of these. 1522, 1, 2. Nope, there's only 2. 1513. Nope. 1498. There's 3, but it's that's still not beating 1494. 1473. There's only 2 of those. Okay, I think it's fairly obvious we're not going to beat 6, so the mode is 1,494 boxes of chocolates. Okay, so we want to fit as many of these into this box. Now the key dimensions are it's 22 high, so that means we can 48 divided by 22 is 2 point something, so we can definitely get 2 in height wise. There'll be a little bit of a gap. How many can we get going across? Well, it's going to be affected by its diameter, so 11. 55 divided by 11, so we're going to get so there's 2 height wise. 55 divided by 11 is 5, so we'll get 5 along here, 2, 3, 4, 5, and it's also 55 down here, so we'll get 1, very hard to draw, 1, 2, 3, 4, another 5. So in total, the number we will have is 2 times by 5 times by 5. 2 times 5 is 10, 10 times 5 is 50. So we can get a total of 50 boxes of chocolates in there. There we go. So all those workings out probably should have gone in this box. Okay, so we need to do the plan view. So if we're looking from above, so we're not going to see the fact that there was a set stacked on top of the other. We're only going to see the top. So we're going to have it was 5, 1, 2, 3, 4, 5 by 5, 1, 2, 3, 4, 5, and we'll just see the circular tops like so. Probably could have drawn it a little bit more neatly, and we know that actually it was pretty much it was 55 centimeters, wasn't it? And because it's 55 by 55, then there should definitely be no gaps, so perhaps just make sure that there's no gaps. In fact, it should be a square, not a rectangle, so maybe just delete this bit around the edge there. Okay, We also want the elevation. So if we're looking at, the elevation of side A. So this is side A here. So I've already done a little bit of it. So we're going to see 5 along the bottom and 5 along the top. So it's 55 by 48. So it is a rectangle. And there will be a little gap, as I say. So maybe they come up to here. There we go. So 1, 2, 3, 4, 5. Done. Okay, bit of a very rough sketch that one, but I'm sure that will be fine. Okay, let's take a look at activity 4. So we know that the scale is 1 to 40,000. Probably, given the fact that the grid is in centimetres, it's probably worth turning the 5 kilometres into centimetres. So 5 kilometres is 5,000 metres. Remember, there's 1,000 metres in a kilometre. There are 100 centimetres in a metre, so multiply 5,000 by 100, just stick 2 zeros on. So that is the distance that he is running in centimetres. Okay, so how many centimetres on the scale has he done to go from A to B? 1, 2, 3, 4, 5 centimetres. So 5 centimetres, what is that in real life? Well, that's going to be 5 times by 40,000. And 5 times by 40,000 is 5 times 4 is 20. Put those 4 zeros in. So that is 200,000. So 5 centimetres, which is 200,000 centimetres in real life. In brackets, I'll put the real life. So here we've got 1, 2, 3, 4 centimetres. So that is 4 lots of 40,000. 4 times 4 is 16. Put the 1, 2, 3, 4 zeros back in. So that is 160,000 in real life. So far he has done, in fact I should probably use the actual workings box here, 200,000 plus 160,000. That is 360,000, and we've worked out that the total was 500,000. So how many centimetres has he got left to do? 500,000, take away 360,000, which is 140,000 in real life. So we're going to use the scale to turn the 140,000 into centimetres on the actual on the map here, or on the graph. So that's going to be 140,000 divided by 40,000, because remember the scale is 40,000 times less than real life, and 140,000 divided by 40,000 is 3.5. So therefore we need to extend this line to D 3.5 centimetres. 1, 2, 3.5. So this is the point D, and we can just extend it like so, preferably using a ruler. Okay, so it took Kyle 45 minutes to complete the run, which was 5% longer than his previous time. So his previous time increased by 5%, and it gave us this new time of 45. Now, when we're increasing by 5%, we would have multiplied by 1.05 to get 45. So if you've not followed where this number comes from, the multiplier for 5% is 0.05. It's this figure here divided by 100, but when we want to increase by 5%, we just add 1 to this figure, so 1.05. So if you wanted to, let's say, increase £66 by 5%, it'd be 66 times 1.05. So his previous time was multiplied by 1.5 to give us this new value of 100, so his previous time would be 45 divided by 1.05, and that comes to 42.85714. We only want 2 decimal places, so we're interested in the value of the 3rd decimal place. It's greater than 5, so that will round up to 42.86 minutes. Okay, so let's take a look at 4C. So we need to plot this, we need to do a scatter diagram. So probably what I would do, I would make sure that on the horizontal I'd have the temperature, and up the side I'd have the time. So looking at the temperature, we've got 2, 4, 6, 8, 10, 12, 15 squares, and we're going from 6 to 25, so that's 19 degrees. So we can't have 1 square per degree. So I'm going to go 2 squares per degree, starting at 6. So 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. So I'll label this, make sure my axes are labelled, so temperature, and that is degrees Celsius. I've also got 15 going up the sides, and the time taken goes from 52 down to 35, and 52 minus 35 is 17, so I can't go up in ones, so I'm going to have to go up in twos. So let's go 34, 36, 38, 40, 42, 44, 46, 48, 50. That seems like a bit of a waste of 52, 54. Yeah, it's the best we can do, really. Okay, the more fully we use the graph paper, the easier it is to actually plot the data as well. So this is time in minutes, so let's label that axis as well. So this is time, and that is in minutes. Okay, right, let's just plot the points. So we've got 17, 46, 14, 16, 17, 46. So I'm not going to, I probably should be really accurate, but that it could take forever, so I'll just do a bit of a rush job on this. So 12, 38, there's 12, and there is 38, right there, that's pretty good. 25, 52, 20, 24, 25, and so it's halfway between 24 and 26, and we want 52, which is about here. 9, 36, 6, 8, 9, I've already forgotten what the other value was, 9, 36, so there. 10, 37, so there's 10, 37 will be here. Oops, a little bit low, that one, never mind. 22, 50, this one's actually one of the easy ones to plot, right on that corner there. And finally 6, 35, so 6, 34, 35, halfway between 34 and 36. There we go. Okay, so I have produced my scatter diagram, there we go, and we want to use this to calculate his likely time to run the half marathon. Okay, now this has got nothing to do with running a half marathon, this is all about running a 5k, but we've got a formula here which can turn a 5k time into a half marathon time. So first of all, we know that the forecast is 15 degrees C. So what we need to do before we do anything is put in a line of best fit. Now this line is going to cut through the centre of the data, trying to keep an equal number of dots on either side of the line, so this would be a terrible line of best fit, so would that, so somewhere in between. That's about right. I mean, it's the sort of thing you could ask 10 students to do and they could come up with 10 slightly different lines, but they'd all be equally valid. So we want to work out that if someone is running at 15 a temperature of 15 degrees, so there's 16, so 15 is halfway in between. So let's go up in between these lines. So really important you use a pencil and a ruler, and I'm hitting the line there, and I'm getting approximately 42 minutes. So let's call that 42. You might not get exactly 42 because your line of best fit might be slightly different. It also might be a bit thinner than mine. Mine is far too thick, so you might get a slightly different reading, but that's fine. As long as you can show how you've got there and it's within a reasonable range, it's fine. So, so 5k prediction is 42 minutes. Okay, so what we need to do is, first of all, we need to turn, well, we've got D, the distance in kilometres, and that is the distance of the half marathon. So 1 mile, so we know that 1 mile is 1.6 kilometres, so therefore 13.1 miles is going to be 1.6 times by 13.1, and 1.6 times 13.1 is 20.96 kilometres. Okay, so we've got our D, so we've got 20.96 divided by 5 multiplied by 1.12 times T, which is the time to run 5k in minutes, which we think is 42. So let's go for it. 20.96 divided by 5 times 1.12 times by 42 minutes, and that comes to 197.19168. That's quite a long time. So that is 197. Does it say it's the nearest minute or anything like that? No. Let's just leave it like that then. 197.19. That'll do. Okay, on to part E. So we know one lap is 320 metres, and he's going to go around it quite a few times to do 15k. Now, 15 kilometres, that is 15 times 1,000, so it's 15,000 metres. How many 320s are in 15,000? So 15,000 divided by 320, and that is 46.875. So what this means is he's going to do 46 full laps. So every full lap will take him back to A. It's this last bit. Now 0.875 is 875 thousandths, and that is the same as 7/8. So what that means is, actually we don't even need to turn it into 7/8. We can just say it's 875 1,000ths. So what is 875 1,000ths of 320 metres? So 875 1,000ths of 320. So here we're calculating a fraction of an amount. So we take our total, we divide it by the number on the bottom, and then we multiply by the number on the top. And it doesn't matter if you use 875 over 1,000 or 7/8, we'll get exactly the same answer, and that is 280 metres. So it'll be 280 metres of the way round on that final partial lap. Okay, so we've got this important bit of information, which is that he's run exactly 0.8 of a lap. 0.8 is 8/10. Now when he's done the full lap, he will have done the full 360 degrees. So all this person has done is 8/10 of 360 degrees. So just like the previous question, we're working out a fraction of a total. So we take our total, we divide by the number on the bottom, and then we multiply by the number on the top. And 360 divided by 10 multiplied by 8 is 288 degrees. So this angle here is 288 degrees. And that takes us to the end of the assessment.